ফ্যানটা চালাও, ফ্যানটা চালাও।
Let's start. So the syllabus and the introductory content already uploaded. So is there any queries related to the last class? Like you have seen something and you have some questions in your mind? Anyone? Any queries? Anything you not understand properly? Okay. I hope you already start to see the things because you have many important subjects in the semesters. Therefore, please utilize your time. And before starting of every class, I like some interactive sessions from your end. So that will be good. Also for the offline classes, we will start from next week. So some interaction, your queries, like where you have some difficulties to understanding some concept that is always the definitions of keywords related to the items, how of what is associated with anyone, some keywords, key term, what we have discussed during our last class. So the two terms we have discussed during our last class. One is the resource allocator, like which will manage all the resources, and another is the control program. These are the key features of operating systems. We had studied several computer systems architectures and operations. We have discussed the time sharing and the job sharing task of operating systems. These are the some features, some important features. And lastly, we have discussed that von Neumann architectures, which is one of the basic architectures for any modern computing systems which will work, and there are three components. Okay, so I think we can start from here today. So therefore, again, I am saying your participation is very much required. I'm just sharing my screen. Is this screen visible, students? Is the screen visible? Hello, anyone just speak, otherwise.
Yes, sir.
Okay. So again, I just like to ask you, what is the role of the operating systems in this architecture? In case of von Neumann architecture, what is the role of operating system? How we identify the role of operating systems for this architecture? So particularly to identify the role, I just like to repeat one thing, that operating systems reside inside the main memory. The memory is the location where after boot operating systems loads, and there this is an software applications having multiple features, or let's say multiple features to manage the devices and also to manage the CPU itself. Like so therefore it will generate multiple instructions. Operating systems generate multiple instructions to the devices and CPU as well. That instructions will pass through, for example, for the devices, that instructions will pass to the operating systems through that DMA, or direct memory access, like the bus which will connect it to the device to the main memory and facilitate us to do the direct memory access. Okay, and in another side, that CPU is there. CPU will provide its pulse. Pulse means this is the working force for all components, the devices, the memory, everything will be executed as per the energy which is getting from the CPU. So therefore, that this is the third component, device, memory, where the operating systems reside, and it will generate multiple instructions. That instructions will be passed to the CPU, or let's say the exchange of information from the CPU to memory is done through the instruction execution cycle. And for users, will interact with the systems through interrupt. So there will be two types of interrupt. One is software-driven interrupt, like the applications what are running. If this will provide some interrupt to the systems. Interrupt means some sort of executions. Interrupt happen in course of some executions of some applications program or executions of the IO devices through the users interactions. Interrupt occurs by interactions. Interrupt occurs through interactions. Interactions from the software applications, interactions from the users through IO devices. Okay, so that's the procedure of doing that, and you see the data transfer will done accordingly. The IO request will come to the devices, and as per that IO request, that interrupt will execute, and this will execute through the CPU. So that you should always know, like when you just try to think about the von Neumann architectures. Anyone asks you, what do you know about von Neumann architectures? In von Neumann architectures, will define the basic functionality of the computing systems. The von Neumann architectures having three components like CPU, memory, and the devices, and they are interconnected with each other. So operating systems reside inside the memory, and it will generate multiple instructions to execute different interrupt, which will generated by the interactions from the users and the software applications like this. Let's say the conceptual understanding of some components is very much required in this point. When you are just describing some things, you should make it habit, like you have that grasp about some concept like this. Okay. Uh, so now when I come to the functionality of the operating systems, there are, so let's go through with some keywords what we are learning uh, in this course. Multiprocessors, you know that term. Multiprocessors means what? Multiple processors will execute some task. So multiple processors will execute some task. Now, as per the designing point of view for the computing system architectures, that multiple processors are integrated or fabricated inside one single components. Okay, so let's say when I use the term dual core processor, quad core processors, octa core processors, that means what? Multiple processing units are fabricated or integrated inside a single components. Correct? So that is multi processors. Is there any queries or questions someone asked? See, so I'm not able to see it. Just allow me. Is there any questions? No? I thought that someone asked me some questions here. If you have any queries, you please unmute and just speak, because I'm not able to see it during the class. So therefore, when I am considering these multiprocessors, some terms is coming with it, which is the parallel systems. That means all these processing cores are parallelly run, and these processing cores are tightly coupled. Tightly coupled, why? Because this is fabricated inside a single components. Therefore, this is tightly coupled system. And when I consider these multiprocessing units, it having certain advantages. It will increase the overall throughput. It is, of course, more economical than fabrications of different processing units, because you see, inside one processing units or inside one single components, multiple processing cores are fabricated. Therefore, this is more economical, and it will increase the reliability. Why? because you have multiple processing cores, and if there, for example, if some cores are having some latency or some execution fatality, then other cores can take the responsibility to executions of some process. Therefore, it will make my systems more reliable. Okay, and this is known as uh, so this may uh, degrade the overall execution speed, but it will never halt that operations. Therefore, this is known as also graceful degradation. Degradations of overall computations in compromise with that things that my systems will remain reliable. Therefore, it is also known as graceful degradations features of multiprocessing systems. Now I come into the category of the multiprocessing systems. There are two different types of multiprocessing units. One is the asymmetric multiprocessing, and another is the symmetric multiprocessing. In case of asymmetric multiprocessing, each processor is assigned a specific task, or one task is assigned to each processor. So when we have asymmetric multiprocessing systems, so that means there will be no all processors will integrate. You have individual processors, and each task will assign to one processors like this. And in case of symmetric multiprocessing, each processor performs all tasks. That means what? If I have, let's say, I have 10 tasks to execute, and I have four processing cores to help this execution process. Now, that 10 tasks will be time shared among these four processors. So when I consider this term time shared, means the CPU time will be shared among all these processors as per the optimized way of executions for these 10 processors. So again, I am using the term optimized. Now that how that optimization done, that is depend upon the algorithm or that scheduling algorithm, how it will sharing the time among all these four processors. So, but the thing is that in case of symmetric multiprocessing, one single processor will not associated with a single task. Rather, all processing units are associated with all the tasks what need to be executed. Is this clear, students? If you have any queries in this point, you please ask me. Asymmetric multiprocessing, symmetric multiprocessing, the features of the parallel processing for the multiprocessors are very important concepts. Okay, so now we see very basic structures of these multiprocessing architectures. Let's say there are three different processors which will associate with memory, and this is a type of symmetric multiprocessing architectures. In this case, each task is assigned to a particular processor, and it will execute that these tasks accordingly. And in case of multi-core systems, or let's say symmetric processing systems, you have multiple core, and as I mentioned, the task will be distributed among the multiple core of that particular processes. Okay, so that's the difference between these things. So for the distributed systems architectures, we can having the similar applications of these symmetric multiprocessing or asymmetric multiprocessing for the clustered systems. Cluster means what? Some sorts of more than one computing systems are integrated together to facilitate the executions. Now, in case of clustered systems, when one particular task is assigned to a particular processors, then this is known as asymmetric clustering. And for symmetric clustering, have multiple nodes running the applications, and it will monitoring each other and having the connectivity among different processing units like this. Just a moment. Okay. And this is used in case of high performance computing, which will use the similar concept of parallelization to executions of some tasks. Please note that when I consider the optimized execution of the task, parallel processing is fine, but sometimes we need to combine the parallelism and serialism. Like, let's say 75% parallel processing, 25% serial processing. Okay, that can optimize the overall performance of the system. In case of high performance computing, these are uh, taken care. Now again, what is the role of the operating systems for doing that, to managing these things? How this will managing these parallel mode of executions or serial mode of executions? There are some programs which will execute and just define how this will actually manage. Okay, so this is a very basic structural things of the clustered systems. When you have multiple computers which having interconnections to the SAN or storage area network, and there you can easily find out for any task for this symmetric cluster. This will be distributed, the task will be distributed among multiple computers, and in the course of executions, this is more this will give some more reliable results. When we are considering the modern cloud computing systems, this is some advanced form of these clustered systems where you have some more additional features which are actually integrated. One of the important features of these cloud systems or cloud computing systems is the elasticity. What is elasticity means, you see the nature of the elastic is it will increase the size when it is more, the volume is more, and it is decrease the size when its volume is less. In case of cloud computing, these features are used. This will actually optimize the overall executions, and you have different components of the cloud architectures. For example, software as a service, platform as a service, then uh, this is what else? And this is SaaS, EAS, and infrastructure as a service, IaaS. These are the three different components for the clustered based systems. Okay, so for all these type of infrastructure, you have some dedicated operating systems which will managing these things. Okay, so now in order to facilitate this multi-processing,